Now we'll go ahead. Just see this. Now stability failures are vertical and lateral loading, and these are the few terms actually which are uh, stability issues. So there is a uh, structure collapse due to overturning of the structure. There is a term lack of anchorage. We will see in detail. Structure may fail due to sliding, fail or collapse. Structure may fail due to the sinking of supports or differential settlement. It may fail. Buckling of compression members like columns, we can say. Column may buckle, and lateral torsional buckling of beams or columns. So these are the important, we can say, stability failures you should know. Now, if you look at all the terms, there is no AST, there is no grade of steel, there is no size of member, there is nothing. These are very different terms actually. So don't use the word safety or strength or material or something. So they are secondary important. Yes, they are important. We will see this. I think I will take this slide at the end. Okay, fine. Now look at this building. Can you see this? Can you see this failed building? What is this? Is it sliding, overturning, sinking? What do you want? What do you say?
It is overturning.
It's overturning, right? You can see this is overturning. For example, the structure was like this previously original condition and it fall down like this, right? So overturning. Okay. Now see, look at the structure here. All the beams, whatever they are there, there is no even a crack, single crack. We can see this visually. All columns, beams, and maybe slabs are in really good condition. That means whatever you have designed for this building and whatever steel you have provided, thickness of beams, sizes of columns, whatever, they are okay actually. So design is really okay here. If you look at this part, design is correct. I think so. Yes. But there are no any cracks, but the building still collapsed. Building still collapsed without any cracks in the beams or see the surface. We can really understand that there is no many distress in the columns. Is the reason it fell down.
Due to settlement, differential settlement.
Yes, there is a possibility of differential settlement. Correct. So if the this failure is due to the gravity load, then in gravity, generally what happens in the gravity, we'll discuss this. Okay. So gravity load. Let's say this is your building. Generally, in gravity, the loads are vertically downward in the gravity directions, right? So, ideally speaking, the building should not collapse in the gravity loads. Okay, generally, even though there is some error in the design, there is a possibility that building. You know that there are many buildings in India which are not designed by the structural engineers. Do you know unauthorized construction? There are unauthorized constructions in India which are not designed by the structural engineers, like low villages or like that. And do you know that even though unauthorized construction without any design, if you do the calculation of that building, you will see that the calculations are saying that your design is wrong. The building is unsafe. Okay, unauthorized construction, I'm saying. But you will see that the building is there since 10 years, 15 years, right? Then why it is standing? If the calculation is unsafe, then why it is standing? This question may come in your mind, isn't it? आ सकता है ना किसी क्वेश्चन, अरे ये बिल्डिंग 10 साल से खड़ा है, इसको डिजाइन नहीं किया, कैलकुलेशन मैंने इंजीनियरिंग मॉडल किया, ये किया और अनसेफ दिखा रहा है, फिर खड़ा क्यों रह रहे हो? That is what I'm saying, that the failure reason is not really the design or analysis. In general, I'm saying, I'm not saying that that is not the reason, but in general, design may not be the reason of the failure. Analysis may not be the design of the say, reason of the failure. But there are some major things which are creating this failure. Okay, so these major things, let's try to understand. Now, if this building wants to fall down in the gravity load, what is the reason? As you said, actually, now that there is a possibility that the footing may fall down. And why footing? There is a differential settlement. If this is the case, let's say this is your footing location, and let's say if I say that okay, say that this zone is having a soft strata. Okay, let's say, see, underground, you know that there is a difference in the strata condition, and let's say that this blue color is a hard strata. Okay, so this left side footing is resting on the hard strata. It may be a hard rock. Let's say this is a hard rock, and let's say this is very clay soil, soft soil. That means there is a possibility that there is a more settlement than this, that we call it as a differential settlement. Okay, so that means this footing will go down after load application, after say few months or few years, whatever. Now there is a big displacement gap, you can understand here. Okay, so there is a displacement too much. Now, even though your design of the column beam slab is really good, you know that if there is a displacement of the footing in the soil, then your moments in the column beams will increase 10 times, 20 times, 100 times, whatever. See, this is the very, very big number. Do we design? See, there are factor of safety like 1.5, 2, whatever. And if your moment is coming 10 times or 20 times, then this structure definitely will collapse. This is the one reason sinking of supports or differential settlement. This can be said as a sinking of support. And then there will be huge crack in the building. Let's say it may happen that either building will topple down or there will be cracks like this. Okay, and this portion will try to go down, and there will be huge cracks, and due to these huge cracks, again the building will fall down, and finally there is a huge collapse. So you might have seen the structures where there is a collapse due to the gravity loads, and it is not the gravity load, but it is due to the sinking of supports. Why sinking? Because the strata, you are not putting the footing on the hard strata. That is the reason. So that means why it happens. So there are why either there is a natural soft soil. Natural soft soil may be clay or black cotton soil, or there is an artificial soft soil, which is, we call it as a filled up soil, filled up land. Do you know that if you, there are some, many times this land is filled up
Yes, sir.
with external soil. So filled up soil, we call it is. And let's say this yellow color is a filled up zone, and definitely it will fall down. So the sinking of support reason is we are not putting the footing on the hard strata. Now this is the big reason of failure of structures under gravity loads. Nothing related with design, nothing related with analysis, but something related with the foundation settlement. Okay, main reason of the failure of the structures. So whenever you do any design for your projects, make sure that your footings are resting on the hard rock. Make sure that you have done the geotechnical investigation. Okay.
सर और एक बात है.
हाँ.
हेलो सर, इसके बारे में भी बताइए सर, पंचिंग शेयर के बारे में थोड़ा. वो भी
Uh,
फेल.
punching share we will discuss separately. Okay, we will definitely discuss on that, but may not be today, or at the end I will discuss on that. Okay. Now, let's say, then you can understand that due to that settlement, the building will tilt. So first, what will happen? Same building I'm saying. This building will tilt like this due to the settlement, for example. And you know that when the building tilts, now the center of gravity is, you know that the load is like this, and the original position was like this. So this is your vertical downward load, and there is eccentricity. Previously, there was no eccentricity. When there is a vertical load, the load passes through the CG. So there is E is equal to 0 almost. Okay. No eccentricity. As there is no eccentricity, there is no moment due to the eccentricity. Okay, so this vertical load is there P, but as E is 0, overall moment is 0. But when there is a tilting due to maybe sinking of the support, there is a P into E, and this moment is there. Now this moment will again rotate the building. Again, there is an additional load. Then the building will tilt and the P will shift here. Again, the E will increase. Again, P will shift. Again, E will increase. So there is a, we can say, iteratively the building will slowly go down, and it will finally collapse down. Okay, so this is the overturning failure. So the sinking of support may cause the overturning of the building slowly, because this will go down, it will overturn, then E will increase, again more moment. This M1 is first, let's say M1 is 50, then M2 is 70, M3 is, say progressively it will increase and it will fall down. So that is the overturning failure also, we can say. And why it is happening? Because of this E. And why this E is created, that eccentricity, because of the sinking of the support. So this is, we can say, sinking of support was the first reason where the building started collapsing. Then due to sinking, the E increased, moment increased. As moment increased, again E increased, again moment increased, and slowly it fall down, right? So this is the, we can say, overturning failure for buildings. Now overturning, this is a gravity load, I said. Now there is maybe some different